This lesson today is on combination circuits. They're called combination circuits because they have parts of the circuit that are parallel and parts of the circuit that are series. And they're going to look just like this. This is the easiest one that I can draw on the board. It's going to have a battery. Let me get a different color here right quick. It's going to have a battery, okay? And then it's going to have a resistor there, and it might have a resistor here, and then it's got another resistor here. And let's put some numbers in. Let's make this 12 volts. Let's make this 2 ohms. Let's make this 3 ohms, and let's make this one 6 ohms. Okay, so this is a combination circuit. Now let's talk about the parts. First of all, you should be able to recognize that this part right here is the parallel part of the circuit. And then you should be able to see that this one, this 2 ohm resistor, is a part of the series. It's in that single loop before it gets to the parallel part. And what I've listed here are the 5 steps for solving these problems. And it's really important that we follow those steps to get the answers. In fact, there's an answer for step 1. There's an answer for step 2, and so on, 3, 4, 5, all the way down. And so let's start out by doing step number 1. It says do the parallel resistance first. So you know that in a parallel circuit, this should be 1 over 3 plus 1 over 6 equals 1 over R total. And we have a common denominator, so the common denominator is 6, so that's going to be 2 6 plus 1 6 equals 1 over R total. So that's going to be 3 6 is equal to 1 over RT, like that. And then you should remember that the first thing I said to do was to flip it over. So when you flip that over, this is coming to the top and this is going to the bottom, so that's going to be 6 over 3, which is 2 ohms. So the answer to step number 1 is 2 ohms. Secondly, when you do that, I want you to put the 2 ohms in parentheses right there. That shows me that this whole parallel chunk right here has a resistance of 2 ohms. Now, step 2 says do the series resistance second. Well, we know in a series circuit, we're supposed to add them up. So when we get to here, that's 2 plus 2 is 4. So the total resistance is 4 ohms. And it's like that 2 represents everything that's over here. So you can see that 2 plus 2 is 4. Now, the magic triangle. When we set up the magic triangle right here, the voltage goes on top. Well, that's a 12 volt battery. The total resistance was 4 ohms. So we put the R right there. The I stands for current, and that's the thing that we don't know yet. But when we solve for it, 12 divided by 4 is 3 amps. So we got 3 amps flowing out of the battery. Now, step number 4 is the voltage drop. This tends to be one of the things that kind of gives students some trouble, but it's the current times the resistor. So 3 times 2 tells me that I'm going to lose 6 volts as it goes through that resistance right there. And then as that current comes over to here, 3 amps times 2 is going to give me 6 volts that are going to be dropped there. In a series circuit, remember the current is the same everywhere, so that 3 amps is that 3 amps, which would still be 3 amps as it goes back into the battery. So we have 6 volts lost in that first resistor, and then we have 6 volts left to be used for the parallel part. So in the voltage drops over here for number 4, I would have put 6 volts, comma 6 volts, because that's the first drop, that's the second drop. Remember or notice that the voltage drops always add up to the total voltage in the battery. Now, step number 5 says using the loop rule. Well, when we were doing the loop rule, when it was just parallel, we always used the whole voltage that was coming from the battery. But on a combination circuit, we're losing 6 volts before it ever gets to the parallel part. And 6 from 12 is 6. So when we do the loop rule, this side gets 6 volts, and this side gets 6 volts, because that's the only voltage that's remaining to be used for the parallel part. And you'll remember that I1 is going to be 2 amps, and I2 is going to be 1 amp. And as we learned before, I1 and I2 should add up to the total current in the circuit. Now, that is a great example of combination circuits. It also is a good example of how we get the answers for each part. I didn't write this down, but this I1 should have been 2 amps, and I2 should have been 1 amp, and we should see that those add up, like I said. So you get points for this, you get points for this, you get points for this, you get all the way down. But it's very difficult to solve this circuit without following those steps. If you have any questions, email me. Otherwise, have a great day.